Hello students, today we are going to discuss about intrinsic and extrinsic semiconductors. Semiconductors are mainly classified into two types, that is intrinsic semiconductor as well as extrinsic semiconductor. So intrinsic and extrinsic semiconductors are two different types of semiconductors. Extrinsic semiconductors. As we all know, the good examples for semiconductors are germanium and silicon. When we are taking a silicon semiconductor or a germanium semiconductor, if it is in its purest form, then we can say that that is a intrinsic semiconductor. So if the semiconductor is in its purest form, then it is a intrinsic semiconductor. And if there is some impurity, or if we are adding some impurity to make it more efficient, then it will be extrinsic semiconductor. Then how we are adding impurities to a semiconductor? For that there is a process called doping. So we will be doing doping to improve the efficiency of the semiconductor. Then when we are adding impurity to a semiconductor to improve its efficiency, that process is called as doping. And with what material we are adding those impurity, or with what material we are doping, that are called as dopants. So the examples for dopants are arsenic, gallium, etc. So these are some impurities or some dopants which we are adding in a semiconductor to make it more efficient. Okay, so now let's see what is the difference between this intrinsic semiconductor and extrinsic semiconductor, why we have to improve the efficiency. So let's say if we have a silicon semiconductor, this will be its valence band and this will be its conduction band. So when it's in the purest form or at 0 Kelvin, all those electrons will be in its valence band, right? At absolute 0 or 0 Kelvin, everything will be in the valence band. But when it is in the room temperature, this valence band will be getting heated up, or with some external energy, it will be getting jumped into where? The conduction band, right? So if it is in a room temperature, then we will be calling it as a insulator. So semiconductor which is in its purest form is called intrinsic semiconductor. So even I have told what is a semiconductor. Semiconductor is nothing but a solid substance whose conductivity lies between the semiconductor as well as the insulator. Now I am coming back to the point why we are adding impurities. So when it is getting heated up, what is happening? This valence electrons will be jumping into the conduction band for conduction, right? Then there will be a conduction. We will be converting that as a semiconductor. If all the valence electrons are in the valence band, then this is an insulator. So when it got heated up or at room temperature, if some electrons jumped into conduction band, then it is a semiconductor, right? So let's see the crystal structure of a silicon atom. So this will be your silicon atom. It will be having 4 electrons in its outermost orbit, right? If we are making a crystal of silicon atom, then let's say here also one silicon atom was there, here also one silicon atom was there. So for both the silicon atom, you will be having 4 electrons as well, right? So here they will be forming a covalent bond, which you have already learnt, right? So everywhere they will be forming covalent bond with a nearby atom, nearby silicon atom. So covalent bond will be formed. When it comes to a extrinsic semiconductor, the same silicon atom I am taking over here, we can add impurities to make it more strong or to improve its efficiency, right? So silicon atom was here, silicon atom was here, silicon atom was here. So each of them were having covalent bond between them, because we are forming a crystal, right? So crystal, even you know, you have learned it in your chemistry that it will be, I am just drawn a small pattern of a silicon, it will be going like this, it will be coming over here and it will be going like here as well. So now let's see how we can add impurities to a extrinsic, or how we are adding the impurity to a crystal of silicon. So we know that the adding impurity process is called as doping, and the material which we are adding are called dopants. So these dopants can be classified into two main types, that is donor dopants as well as acceptor dopants. So the example for donor dopants are arsenic and acceptor are gallium, which means if we examine the outermost shell of arsenic, we can find out 5 free electrons, which means when we are replacing this with arsenic, what will happen if we are donating? We are donating a electron. So here we were having 4 electrons. When we replaced it with arsenic, now we are having 5, which means 1 free electron is there, right? Here when we are replacing semiconductor silicon with gallium, then what will happen? Gallium is having 3 in its outermost shell. Here you can find 5 in its outermost shell, and when we are speaking about gallium, it will be having 3 free electrons in its outermost shell, right? So this will be accepting, because here when gallium is replaced with a silicon atom, 4 are there. When it is replaced, 1 electron become positive, right? It will be creating a hole. So based on this, extrinsic semiconductors are mainly classified into N-type semiconductor as well as P-type semiconductor. N-type and P-type semiconductor. So this N-type and P-type semiconductor is derived by with what material we are doping, which means if we are doping a semiconductor with a trivalent impurity, then it will be P-type, and if we are doping it with a pentavalent, then it will be a N-type, which means in N-type the majority charge carriers will be free electrons, which is electrons, and in P-type the majority charge carriers will be hole, because in P-type we are doping it with trivalent, which means 1 electron, 1 pair, 1 place is left, wherein that will be changed into a positive sign. In N-type the majority charge carriers will be electrons, and in P-type the majority charge carriers will be holes. So in this video we have learned about intrinsic and extrinsic semiconductor. If the semiconductor is in its purest form, that is called as intrinsic semiconductor. This is the crystalline structure of a semiconductor, and when we are adding impurities to improve its efficiency or conductivity, that process is called as doping, and with what material we are doping is called as dopants. Examples are arsenic and gallium. Again, this extrinsic semiconductor is divided as N-type semiconductors as well as P-type semiconductors.